I would like to take up voltage to current converter. As the name suggests, the circuit which is going to convert the applied input voltage into an output current, or else the output current is going to be proportional to the applied input voltage. Here this circuit is connected in terms of floating load. Means whatever the load we are going to connect, that is not going to be connected to ground, rather that is connected to some other node point, and that's why we are using the word floating, not connected to ground. And the same circuit seems to be a current series negative feedback amplifier circuit. Why? Because the output is going to be considered as current, and that is going to be connected, whatever the potential that is developed because of this output current or the feedback voltage across R1 resistor, this is going to be in series with the applied input voltage, and that's why at the input side we have series connection, and at the output side we have output current, and that's why this sort of feedback configuration can be called as current series negative feedback amplifier. Now writing KVL at the input side, and here we have Vf, and here Vin, and here we have Vid. If I am going to write from this direction, here minus plus, here plus minus, and here as the current is going to flow in this direction, here plus minus. Therefore this is said to be different from these two. Therefore I can write it as Vin equal to Vid plus Vf, but Vid is equal to 0 because of virtual short. Therefore simply we can write Vin equal to Vf, and Vin equal to Vf is nothing but I naught into R1. Therefore I naught can be simply written as Vin by R1. Therefore the output current is proportional to applied input voltage. Therefore this circuit behaves as voltage to current converter. And the applications with respect to this circuit is low voltage DC and AC voltmeters, diode match finders, light emitting diodes, and Zener diode tester. But we can use these circuits to test the diodes. Now let me consider the same topic, voltage to current converter, but with a grounded load. Now you can observe it's the load we are going to connect, and this has been grounded, and that's why we are calling it by the name grounded load. Here if I am going to, because of Vin, some I1 is going to be generated across R, and because of V0 I2 is generated, and the same is these two are going to be added at this node and divided into two parts, IB and IL. But we can neglect IB because it is going to flow through the input resistance of the op-amp, which is said to be infinite. Therefore IB is equal to 0. Therefore I1 plus I2, they are going to flow through RL, which is equal to IL. Therefore I2 plus I1 is equal to IL,